Hello folks, in this video we'll be working on the PCB enclosure. So we got this LCD screen and we need to create an opening here for the LCD, so it's going to be able to show the information displayed by the LCD. At the same time, what we're going to do, we want only to show this area here. We don't want the LCD to sticking out. The idea, as I can see, I don't know if you can see this, but that's the thickness. It will be something. It will be like stopped like that. It'll be stopped like that. I don't know if you can see that. So stuff like that. So the first cutout will go through the whole thickness of the enclosure. First cutout. The second cutout will be the size of the LCD, this external size here, but we don't cut through the whole thickness of the enclosure. We just gonna cut maybe the size or the depth of this one here. So I did some drawing just to show you. So I did some measurement actually, but you can get the measurement from the data sheet. So we're gonna do one cutout through the whole thickness of the enclosure. So this cutout here, so you're gonna go through all the thickness with 2.7 millimeters, and we're gonna do another cutout which is this one, the size of this one, but it's gonna go on maybe the depth of 1.27 millimeters. To do this, first of all, we need to draw this in one of the CAD software. The one I'm going to be using will be the software, the cut2D software. So I will see you there in the next stage. So after we set up what we're going to do on the PCB enclosure, now we need to move to the next stage, which is using the cut2D software to drill our shape, or to drill our cutout shape. So let's run the software. So this is the cut2D software. So you can just start a new project and you do your drawing, all that stuff. You don't want to do that. Or you can just import or open a template, something like that. Okay. This template been created in a CAD Star software. So this was one of my previous projects, but for this demo, I just added the LCD. Well, it's not doing anything. There was some component here, so I deleted it because I didn't need them here, and I didn't want to make things complicated. So for easy demo, so we're just gonna have this car with this LCD. I'm using this PCB as a reference because what I need this hole here. This hole here, this is going to be my 0 reference. This hole here I'll be using to set up my machine, because I can refer this hole here on the PCB enclosure itself, so I can refer to it from this drawing. Okay, so when you start a new project or you import a DXF file or template, you have to set up the job setup. So basically, this one is your working area, or just for example, imagine this is a plastic sheet or something. So imagine, so that's the size of it, and as now it is like just exact size, just to be more comfortable. So I'm just gonna put 100 here. Okay, so let's be moving. So I'm gonna put 200 here. Okay, the thickness of the my enclosure. Thickness of my enclosure, is 2.7. I'm just going to go for 3 mil. and I press OK. As you can see now, so if you please just notice this coordinate here. So that's my starting point, and the 0 is somewhere here. So it's quite a big distance from there. But I want to set my 0 here. The way to do it, we're going to go back to the job setup. We set this to 0, 0, to this 0, and you see now the 0 moved to here. So that's a 0. But I want to put it here. What we can do that, let's zoom into it first. Zoom into it, and then what we can do, we can just, like we're gonna draw, we need this coordinate. You can just position your cursor right in the middle and take a pen and paper and write down this coordinate here. Or the easiest way is just you're gonna draw a circle. So you position your cursor in the middle like so, and when you click on it, this coordinate will be transferred to this draw circle tools here. So you're going to draw a circle. So what you do, you copy and paste this one. So Control C and open any notepad, for example, and paste it here. Then you do the same thing for the y coordinates, and then so you got your x and y coordinates. Okay, and now you close this one. Because we don't need this circle, we're just showing it to get the coordinates, so we delete it. And now you come back here again. So you add minus to the coordinate, because when I've set it with these values here, so you copy, Control C, and then you go to this use offset ticket and paste that value. Where is it? Okay. So we do the same thing for the y and paste it here again. So you click enter. You can already see the 0, 0 move to this point. That's what I want to achieve. So we got our 0, 0 here. So that's what I want to achieve. So all the drawing, all the CNC cutting will be done in reference to this point. So I forgot to mention this, but this is just cut2D software. It's just standard cut software with all the drawing tools, the selection tools, and there is some transfer object here. We're not going to use all these tools. We're just going to use the necessary tools, and up to you if you want to experiment and discover more feature from this software. Okay, so as I imported this as a template, or let's just call it a background. So we rename it as a background. Okay, and then I'm going to add another layer. We'll call it LCD like so. Okay, so if I deselect this, the whole thing disappear. I select it again. So at the moment, the LCD layer hasn't got nothing on it. So what you can do, we want this part to be transferred to the LCD layer. So we select it using selection tools, then right-click, and I say move it to, and you give me the options which layer I want to move it to. So I'm going to say the LCD layer. Okay, so if I untick the background, so I deselect it, so the LCD layer still. So if I select the LCD layer, the LCD drawing disappear. Okay, this is helpful if you got a lot of shapes and you want to mix with other shapes, and you want to select particular shape. So you put each drawing in its own layer. That's for instance, create labels here. You select you create labels, so you create all the labels and you move them to the labels. depend on the tools you can be using. Okay, so we did that. Okay, so we got our origin set up, we got our background set up, we create another layer called LCD. I think you can go from here, but just to show you how we, just for the sake of the demo, we're gonna delete this one and redraw again. And before I do that, I need to get the coordinate of this corner here. We do it in the same way we did with the origin, to move the origin. So we select this circle tools, and we'll zoom right to it until we're happy. So that corner, okay, it's a bit harsh here. Okay, now this coordinate here moved to this place here. So I need to save this coordinate, so I'm gonna do Control C, go back to my notepad, Control V, and then Control C to my notepad, Control V. Okay, that's done. Okay, now we can delete this or we don't need them. So now close this one first, close the tools, then delete that one, select this one, delete it so we don't need it, and we can, just for the sake of them, we can delete this one and redraw them back again. Okay, so in our previous sketch for the LCD that we draw on a paper, so we need to draw first of all the first rectangle. So that rectangle, this is the rectangle, and we need to set up this coordinate that we saved already. So come back here and copy, Control V, Control C, Control V. Again here, Control C to copy and Control V to paste shortcut. And then we will come here and we'll say the size of our external rectangle, which is according to the drawing on X is 2690, 26.9, and in the Y is 7150, 71.5. So you click create. So you create a rectangle, external rectangle with that dimension. As in the drawing before, we need to create another rectangle inside. We need to move inside 5 millimeters in the X axis and 4 millimeter thickness in the Y axis. So we need to do some calculation. So calculate. Okay, so we copy this one first, Control C to copy. So we paste it here. Then we add how many in X1? X we got 5 mil. So we add plus 5. Okay, that's 24. Okay, so we copy that and we paste it here. Oh, sorry, we might have made a mistake because so we we took it from here. So we do that again. So V plus 5 equal Control C. Just for the sake, just gonna save it here, just in case we don't want to do mistake. So we go back to this one here. So the second coordinate, or the Y coordinate, paste it, plus it goes in a Y by 4 millimeters. So just plus 5, 4 equal, so 52. Copy that and paste it here. So this is our second starting port. So we go back to, okay, so come back here and we paste it. Then we copy, Control C, and to paste it, Control V, and then we need to put our dimensions for the internal rectangle, which is 16.9 width and height. It's 63.5. And okay, so we got that, and you say create, and you create the second one inside. So we saved it, Control S. So let's call it exercise something. Let's call it what, test something, test 1. Okay, so save it. Okay, so we just reproduce the same thing we did have before. This is just to show you how to use these tools here. Okay, so we have that now. Now we need to move to the next stage. Okay, so if imagine I have a lot of shapes and things like that. So can deselect that and hit Control. If I want to select all of them, select Control A. So if they are selected, imagine there's a lot of other shapes that we selected at once. Then we press on this icon here where it say switch to toolpaths. So here we need to get our toolpath. Okay, so we are here in the toolpath. Okay, there's two things you can do with this one. This tool here mainly does is going to be cutting through the whole thickness of the PCB, or for example, if you want to create label, you don't want to cut, so we will specify how in depth it's going to go. So for the first one, we're going to select this one, and we're going to select, this is what we select. Then we're going to select these tools here. Okay, you're going to have a number of steps you have to do here. So the first one, we tell it how much deep it has to go. So we're going to tell it to go to 3 millimeters deep, but we're going to do it in stages. The second thing, you need to select your tools. But to do cutting, we're going to use the end mill, the 3 mil end mill. Yeah. And it comes with its own setting. You can change them if you can add your new tools here, but you can change the setting. But so 3 mil. See, this is how much you can, the cutting tools, how much you say 1.2, can cut up to 1.2. And this is the speed of the spindle. This is the feed rate, which is the speed of the cutting tools along the plane XY. And this is when the cutting tools going down to the speed of the Z axis. So I'm happy with that. I don't need to change anything. Okay. So a number to pass, how many times, you can cut it at once, but usually it doesn't do a good job. So because I got only one cut and then cut wash, I haven't got so many, so I can expand on a number of paths. So in this case, you're gonna cut it in 3 passes, and each time you will cut in a depth of 1 millimeter. So I want to ask it to go, for example, 6 times just to have a clean cut. So each time you go half a mil, you cut, you go around the half a mil, then go down a bit, and then half a mil, then half a mil until you finish. So I'm going to set this. Okay. Okay, here you have to set this one because we want to have this exactly the same shape in a cutout. So if I put the tools on the top, we'll cut inside and outside. So I'll tell it not on the top, I'll tell it to cut in the inside. So it goes from the inside, inside we're going to have the same size as we draw in this shape here. The onside, this one on mainly used if you want to engrave. So that one, so that's what it is. Okay, nothing else to change here. Okay, so we're gonna call this one LCD cutout. Okay, so we calculate. Then when you press this, you will calculate the tool path, taking in consideration your input. So that's what it does. So you create a new, so you calculate, so you create this file. I mean, it's not a file yet. I haven't saved it anyway. So it'll show you, for example, what you're gonna do. So if you press this one, you can see. So it went very fast a bit. So this is give you like simulation what it's gonna do. Okay, so if you don't need that, we just close here, and then we need to generate the G code for this one. So to generate the G code, you press this save to toolpath. Okay, so save toolpath to file, and but this I think it's to do with the compatibility of the machines, and our software UCNC is compatible with this Mark II 3 ATC AX. So it will generate a G-code file which is compatible with this machine, which is compatible with our software. So I will say save to path, and then it will ask us to save it to this one. Hold on a minute. Can start. Where's my enclosure? Okay, this was previous previous stuff. So I'll delete this. Okay, this is what I didn't prepare this, so I'm just gonna save it as it is now here. So outside toolpath. I don't know why you say. Nah, see, I prefer to call it the same thing, so I'll call it LCD get out.txt, because when I gonna use this file in CNC machine, I know what it's about. So I'll save this one. Okay. At any time, if you want to change any parameters, for example, you want to change the number of paths, you decide to go for 8, don't know, or change the size of the mailing of the end mill tools, or change any size. So you click and they bring you to this. It brought you to this one. Then you hit recalculate, and it will recalculate in you. Right? Then you have to. It's not going to update the file. You have to do it yourself. So you go back, save to, and you recalculate. Yeah, no, it does it. So okay. So this is how you generate the G code. So if we go back to that file, don't know what is it. Okay, document somewhere here. Somewhere here. G code. Yeah, this is our file. So if we open it, we're just gonna be just text file with some headings, and the important part is this G code here. Okay, so this is the important. This is what the machine recognizes G. This is G. So this one, this is the speed it takes to go 60 millimeter per minute, I think. This kind of So that's your G code. This G code can be used by the CNC machine to cut with our program. So to do a cut like that. Okay, so we close it. Okay, so we can go back to our drawing. Okay, so you can deselect this one, come back to our drawing. So you come back just pressing this one here. Come back to our drawing, add another layer if you want. I may call it, for example. Oh no, sorry, I forgot to do something else. Sorry about that. So go back to the same thing. So we did the first one before. I didn't need to do the second one then. To do the milling, so what I need to do here is select the second tools, which is this one here, and this one, as you can see from the shape, it will take away all the inside like that. So on this one, I'm going to tell it, it's nearly the same setting. So I'm going to tell it to go 1.2 mil. And I need to do it I'm using the same tool, so I don't need to change it. But I just need to change the number of passes. So I'll tell it to go how many passes. So let's say, okay, I'm going to go to in 3 and 4 passes. So each time 0.3 mil. The tool is going to eat up 3 mil. I'm happy with that. In here's climbing. So it's going to go from the outside to the inside, or conventional from. So I don't think it's making any difference. But I'm gonna select this one. By the way, here this is safe set. I mean, when the tools is not milling or anything, what's the size? It's going to be going 6 millimeters above the surface. So I'm just going to call this LCD milling just for me to know. So then I'm going to calculate. Then it generates second kind of file, which is not a file up to now. So this is what you're going to do. As you can see, it's going to eat up a bit by bit and going around like that. You can start from the middle and you go upward until you finish, and you move to the next. Then you move to the next step. Then go down a bit. Then do it again until you do 4 set or 4 passes. Sorry. So LCD milling is the same thing. We're going to generate the G code for it. So save. I'll leave the same name, and that's done. Okay, so that's that done for this one. So we created 2 text file or 2 G code file. One to do the inside shape, which is going to be cutting a hole through the whole thickness of the enclosure, and the second one we're just going to be eating away with the depth of 1.2 millimeter. So it's not going to go through all the thickness of the screen. I mean the PCB enclosure, and this one achieved. So this is going to be exposed, so you will see the LCD information, and this is going to hold the LCD and stop it from going further. So just to summarize, we imported the Excel file from AutoCAD software. The goal was, we did that because we needed this reference on the drawing here. We want to be able to refer it on the enclosure itself. And if you did your design on a CAD style, for example, you will have the silk screen with the position of the LCD or the position of the LEDs, holes and things like that. So it's easy to import the Excel file, and then when you bring it here, you can add or delete whatever you want to delete. That's one thing. The other thing, the software is easy to use, but at the moment we just scratch only the surface. We didn't use most of the tools here, but just showing you the tools that have been needed to do this kind of jobs. So it's up to you if you want to play around with it. I hope this demo was very helpful to you and show you how to use the cut2D software to generate a G-code file to do some works like the cutting through the PCB enclosure, doing some milling, printing some labels, or engraving some labels, or creating some holes. Thank you very much for watching.